40. Stars X and Y have the same luminosity. X has parallax 0.02 second and Y has parallax 0.04 second. So this is a parsecond, which is a unit that helps to measure the distance of some star that really far away from the Earth. Okay. They ask for what is the ratio of between the Bx and the By. So B here is the apparent brightness of X and Y. They ask like how are they compared to each other. So this one will related to the topic E5 and also the B1 as well. So if we study about the fusion and the star, then we can see that this is our Earth here. So this is how we can see the sky here. Like for example, in January, you can see some star at this position here, right? On the right here. But then after about 6 months to the July, it takes like 6 months to travel from this position to this position, right? And another 6 months to return to the original position. So that's like 12 months here. This is a year here, right? So after 6 months, it can move to the other position here. It's like 2 positions of diameter. If we consider that our trajectory orbiting around the sun is a circular, just like a kind of approximation, even though we know that it's not a perfect circle. And the distance, the radius from the sun to the earth is a 1 AU, an astronomical unit. Okay, so now we want to see, okay, in January, you should see the star here. But after our rotating to the new position in July, you should see that the star is kind of like on the left, not on. It's moving, it's moving from here to here. Seems like the star have moved, but it's not that because the star is moving, but because our Earth is moving, right? Just remember the relative motion, the relativity of the motion. Seems like the Earth is moving to the right, right? So then the star will looking like it's moving to the left. So in general, you see that the star here, but then over time, you see that the star kind of moving until in July, you will see it's here. But for the other star that pretty far away, we don't see it's moving at all. It's just like stay there. And this is a parallax effect, okay? The point is that we can determine how far the star is away from us, or like more accurately, more like from the sun, with a D, and this D is measured in parsec, which then you can see this is a right triangle, right? So then we can see that this little angle here, okay, will equal to this angle here. And then because this is really small, it's just like measure in like arc second. So that's why we can just apply the basic trigonometry here. You can see that the values of the angle will actually equals to the side of it itself, right? Or like the tangent itself. So this is the opposite and this is the adjacent. So then let me write again here. The parsec angle here actually equals to the angle here, also equal to this angle here. And we can see that that angle, okay, the angle P will just equals to the tangent value of it because it's very small, okay? Because this one is very small. It's very small. It's just about some second, some arc second. So then it will be the opposite, will be 1 AU here over the distance D, right? So that's why you can see that in order to find the D here, the D that measured in parsec, it's just equals to 1. This is the 1 AU divided by the P that measured in arc seconds. Make sense, right? So basically, we can say that the distance, okay, it will have a relationship with the arc second here. The angle here is what is an inverse proportionality, right? Okay, so that's the equation that you can find in the topic E5 if you're looking into the data booklet. And then for the apparent brightness. So what does it mean by apparent brightness? So for the star itself, if you write here on the surface of the star, on the surface of the star will have a luminosity. Okay, but we are not that near to the star, right? We're pretty far away from it, and because of that, we don't see the star as bright as it is, but we just can see the apparent brightness of the star, how bright the star appears to our eyes from the earth. That's why it's apparent brightness. And that's why it has been dropped a lot from the luminosity of the star. By what? Just imagine like this is the original source, and you can see that on energy, right, have been spread around in a spherical, that's really huge, right? And that spherical surface will have a radius as the distance d here, So that's why, so actually because this one is very, very small, so you can assume that this line is like kind of equal to each other. You can imagine this is very small here, That's why it's just like kind of equal to each other. Here, we just try to draw the angles really huge, then we can see things clearly. But actually, that very small angle. You can imagine that. So again here, luminosity divided by the surface area of the sphere of the radius is d from the star to our Earth, or like to the sun here. And then you can see this is apparent brightness. So now they ask for the ratio. Okay, whenever you see question ask for the ratio or for comparison, just make sure that you set up a ratio. That would be more convenient to calculate, because everything got cancelled later. Okay, let me draw them better, because we should have the x and the y clearly as the subscript. Okay, let me draw again. Let me write again. Bx apparentness of the star X compared to the apparent brightness of the star Y equals to, okay, so we can see that that should be luminosity over these and these. So they have the same luminosity. So I guess that we can cancel on these, right? So what left is just the distance, right? So then it's just basically inversely proportional to the distance square. So that should be x here square, and that should be y here square. So then I will just bring the ratio dy over dx here, and then all together that fraction to be square, right? Like the numerator square divided by the denominator square equals to the fraction itself altogether square, right? Okay, and now we can see that the distance here measured in parsec actually inversely proportional to the p, the arcsecond. So I will just like have another ratio because it's not inversely proportional, so that should be the p of the x here over, oh my bad, this is my Apple Pencil. Okay, sorry about that. And then that just got flipped, you see, x here, now x here, y here, now y here. Okay, so now basically we got the value, right? Just plug it in. X to be 0.02 second over y to be 0.04 second, and don't forget to square them. Okay, so then you will got this is just a half, right? A half, and then you square it. So then you got it to be 1/4, a quarter. So that's why A is the answer. Make sense, right? Okay, thank you. Good luck.